Good morning, students. Yesterday we have derived the formula for finding the solution of a differential equation. So today we see the solution of differential equation where f of x is equal to 0. So first problem we have solve d cube y by dx cube minus 13 dy by dx plus 12y equal to 0. Okay, so this is the given equation and it is a third order, right? D cube y by dx cube minus 13 dy by dx plus 12y equal to 0. So this is a third order differential equation. So to solve this equation, first we write the auxiliary equation. How to write auxiliary equation? So now, as we know that this d cube by dx cube is replaced by its differential operator, that is d cube. So we write this as d cube minus 13, d by dx means d, 13d plus 12. So taking y common, so y equal to 0. Okay, so this we write using a differential operator. So where d cube by dx cube is d cube, 13 minus 13, d by dx is d, next plus 12, then close the bracket, taking y common equal to 0. Okay, so now write the auxiliary equation. So to write the auxiliary equation, just replace d by m. So what we do? So I replace d by m, then it becomes m cube minus 13m plus 12 equal to 0. Next, solve, factorize this equation. So factorize this equation means what? It is a cube, it's a differential equation of third order. Okay, now factorize this equation. Now what we do? We first by inspection method we find one root. Okay, we find one root. Say for m is equal to 1. So put m is equal to 1 or 0, 1, 2, 3 like that, and see for what values of m this equation is going to satisfy. So for example, if I substitute m is equal to 0, so then what happened? This 0 minus 0 plus 12, no, you are getting 12 answer, but we should get it as 0. Okay, next taking m is equal to 1. Okay, so next 1 cube is 1, then minus 13 into 1, 13, then plus 12. Okay, minus 13 plus 1 become minus 12, minus 12 plus 12 is equal to 0. So for m is equal to 1, this equation is going to satisfy. So m is equal to 1 is one root. Okay, so m is equal to 1 is one root, and corresponding to that root we have a factor, that is m minus 1. Okay, for m is equal to 1, for the root m is equal to 1, the corresponding factor is m minus 1. Okay, now we find other two roots. To find the other two roots, apply synthetic division method. So first write the coefficient of this m cube, m square, m, then constant. So here coefficient of m cube is 1, then coefficient of m square, there is no m square term, so it's 0, then coefficient of m minus 13, then 12, then divide m is equal to 1. So you apply synthetic division method, which you have studied in first year or second year in theory of equations, right? So now after applying synthetic division method, so we find the other two roots, that is m is equal to 4 and m is equal to 3, and corresponding to that root we have the factors m plus 4 and m minus 3. Okay, so now we get three roots. So one is m is equal to 1, minus 4 and 3. So which are, now see, all the roots are real, and they are distinct, they are different, right? So therefore we find the solution as y is equal to c1 e raised to x. This is means corresponding to the first root, c1 e raised to m1x. So this is m1, this is m2, this is m3. So c1 e raised to m1x plus c2 e raised to m2x, m2 means minus 4x plus c3 e raised to m3x. So that is m3 is 3x. So this is how we have written this by using the formula. Yesterday we have derived that. So for if the roots are real and distinct, if the roots are real and distinct, say m1 and m2 are roots are real and distinct, then we write the solution as y is equal to c1 plus c2 here. Yesterday we have derived that equation. See here, this one. Case 1, let the roots of f of m is equal to be real and distinct, say m1, m2, m3 and so on mn. So now we have the solution. Then the general solution is given by y is equal to c1 e raised to m1x thus plus c2 e raised to m2x. Okay, so this we have already derived in the yesterday class. So using that we write this solution. So this is the this is the solution of the given differential equation. Similarly, we write solving the second equation. Solve d cube minus 3d square plus 4 into y equal to 0. Okay, again write the auxiliary equation. So replace d by m. So m cube minus 3m square plus 4 equal to 0. Next, factorize this. Then we will get two factors, m plus 1 into m minus 2 whole square equal to 0. Now see here, m plus 1, so the root is m is equal to minus 1. Now see, m minus 2 to the power 2 is there, right? That means 2 is repeated twice, because m minus 2 whole square is there. So this m minus 2 whole square can be written as m minus 2 into m minus 2. That means m appears 2 times. So m is equal to 2 comma 2. That means it is repeated. It is repeated. So therefore the solution is y is equal to the first one is what? It is distinct, that is minus 1. So corresponding to this root we write c1 e raised to minus x. Okay, then plus. Now these two roots are repeated, 2 means they are same. Now for these two roots we write the solution as c2 plus c3x e raised to 2x, because this is a case 2. Case 2 means what? When the roots are repeated. Yesterday we have seen that is here. So when the roots of f of m is equal to 0 are real and distinct, this is case 1, sorry, this is case 2, has root m1 is equal to m2 repeated twice. Now see, this is if this appears twice, then the solution we write this as c1 here, finally this one. Okay, so c1 plus c2, c1x plus c2 into e raised to m1x, means among the n roots only 2 roots are repeated, that is m1 and m2. So for those 2 roots we write this solution. Okay, similarly here in this case this 2 is repeated. So for these 2 roots only the solution is c2 plus c3x e raised to 2x plus the first one, that is minus 1. For this root it appears only once. Okay, so and it is real and distinct, and then this for this root we write the solution as c1 e raised to minus x. Okay, so this is how we find the solution of a given differential equation when f of x is equal to 0. Okay, so next we see a solution of a fourth order differential equation. Now see, solve d raised to 4 minus d cube minus 9d square minus 11d minus 4 into y equal to 0. Now this is, write this equation as, now again write the auxiliary equation, replace d by m. So m raised to 4 minus m cube minus 9m square minus 11m minus 4 equal to 0. Again by inspection method find the first one root by inspection method by substituting m is equal to 0, 1, 2, 3 and so on, and see for what value of m this equation is going to satisfy. Okay, so now here if you substitute m is equal to 0, then it is not satisfying, because you will get answer as minus 4. Okay, but we should get it as 0. And next we substitute m is equal to 1. So when m is equal to 1 means 1 minus 1, this becomes 0, and here it is minus 9 and it is plus 11, because m is equal to minus 1. M is equal to minus becomes plus 11 minus 9. So again you will get 11 minus 9 as 2. So 2 minus 4 is again minus 2. So again for this m is equal to 1, this equation is not going to satisfy. But when you substitute m is equal to minus 1, okay, this is going to satisfy. So therefore by inspection method m is equal to minus 1 is one root, and then find out the remaining 3 roots by using synthetic division method. So then we get the other two roots, and we'll get totally the 2 roots are -1, -1, -1, 4. Okay, -1, -1, -1, 4. Now see here, among these 4 roots, this -1, -1, -1 appears three times. Okay, appears 3 times, and this 4 appears once. So therefore we write the solution as y is equal to, for this solution 4, we write c1 e raised to 4x, then plus, whereas these -1 appears 3 times. So for this we write the solution as it is repeated thrice. Okay, it is repeated thrice. So we write the solution as c2 plus c3x plus c4x square into bracket e raised to minus x. So minus x. Okay, so this is the solution of a 4th order differential equation. Next again here, example 4, solve d cube y by dx cube minus 2 d square y by dx square plus 4 dy by dx minus 8y equal to 0. Again the given equation in the symbol d, we replace this d cube by dx cube, all these derivatives, differential coefficients, by its operator d. So this becomes d cube minus 2d square plus 4d minus 8 into y equal to 0. Now we write the auxiliary equation, replace d by m. So m cube minus 2m square plus 4m minus 8 equal to 0. Now in this case again we write the solution. We find the one root by inspection method, and that root is m is equal to 2. And the equation, we find the other 2 roots, and we get m minus 2 and m square plus 4 equal to 0. So therefore the roots are, one is 2, that is equating m minus 2 to 0, we will get m is equal to 2. Next equate this one, so we will get m square is minus 4, but m is plus or minus 2i. Okay, plus or minus 2i. Now see, this one is real, Okay, now for this root we have the solution c1 e raised to 2x, correct? Next, whereas this root is a complex, it is not real, it is complex. So how do you write complex when the 2 roots are complex? Then we write the solution as, in the yesterday class we have seen that when the 2 roots are complex, that is third case. So here when the 2 roots are complex, say m1 is equal to alpha plus I beta, m2 is equal to alpha minus I beta. So when the roots are complex, we write the solution as y is equal to e raised to alpha x, a cos beta x plus b sin beta x. Okay, so here in this case, sometimes what happened, the complex root, it does not involve, or it does not contain a real part. Okay, it contains only the imaginary part. The real part is 0, so therefore here alpha becomes 0. If real part is absent, then take alpha is equal to 0. If real part is absent, then take alpha is equal to 0. So then it gives what? A cos beta x plus b sin beta x only. Okay, so in this problem, that is here in this problem, there is only imaginary part but no real part, so alpha is equal to 0. So for that we write the solution as a cos 2x plus b sin 2x. Clear? Okay, so either here it is c2 is written, you can write c2 also, or you can write a cos 2x plus b sin 2x. You can take any constant, so either you can take a or b, or you can take c2, c3, because already we have taken c1. So let us continue next constant, that is c2, then next constant, that is c3. Okay, so therefore the solution is y is equal to c1 e raised to 2x plus c2 cos 2x plus c3 sin 2x. So this is the solution of the given differential equation. Now similarly we see here this one, solve d cube minus d square minus d minus 2 into y equal to 0. Again here applying the same technique. Okay, so we obtain these 2 roots. So here, now see here, replace d by m. So m cube minus m square minus m minus 2 equal to 0. Now factorize this, we will get m minus 2 into m square plus m plus 1 equal to 0. Now equate this to 0, we will get m is equal to 2, one root we will get. Then equate this to 0 and we will get this root. So m is equal to minus 1 by 2 plus or minus I root 3 by 2. Now see here, both real part is also present and imaginary part is also present. Okay, so alpha is minus 1 by 2 here, alpha is minus 1 by 2 and beta is root 3 by 2, correct? So hence the required solution is y is equal to, for this root 2 we have the solution c1 e raised to 2x plus, whereas this is a complex root. Complex roots both alpha and beta are present. So first complex root is e raised to alpha x, so alpha is minus 1 by 2, e raised to minus 1 by 2x into bracket c2 cos beta x, beta means root 3 by 2, c2 cos root 3 by 2x plus c3 sin root 3 by 2x. Okay, so this is how we find the solution of a given differential equation using the formula. Okay, first what we have to do is, for any given differential equation, first we write its auxiliary equation. First we write its auxiliary equation. If the equation is second order, or if the equation is simple, and if the equation is second order, then find the two roots. Okay, either by using the minus b plus or minus square root of b square minus 4ac by 2a, or you can factorize. Okay, you can factorize. Then we find the two roots. We find the two roots and see the roots. If the roots are real and distinct, then write the solution corresponding to that nature. Okay, that is c1 e raised to minus m1, c1 e raised to m1x plus c2 e raised to m2x, if the roots m1 and m2 are real and distinct. Okay, if not, if the roots are repeated, okay, if the roots are repeated, see how many times the root is repeated. If it is repeated twice or if it is repeated thrice. Now see, if it is repeated twice, then the roots are c1 plus c2x into e raised to that m1x. Okay, if it is repeated thrice, means one more x square term will increase, so c1 plus c2x plus c3x square e raised to m1x. Okay, like that we write the solution of the given differential equation. Okay, so these are all some exercise or which are given in exercise solution. So just take the screenshot of this, okay, in your mobile, and this one, and then this is also, these are also problems. Up to total 15 problems are there. Okay, 15 problems are there, and in that all the LHS f of x is equal to 0. F of x is equal to 0. So try to solve all the equations, try to solve all the problems, then you can remember the formula very easily, and it is very easy to memorize the formula. Okay, so then you can write, without saying the formula, you can write the solution of all the problems. Okay, so these are the problems, and then these are the answers. Okay, so these are the answers. So take the screenshot of this and then try to solve these questions, right? So in the next class we see what is a complementary function and what is the particular integral. Okay, what is the how to find a complementary function and how to find a particular integral, and this is very important, and that we see in the next class. And with this I conclude. Thank you.